Welcome students, welcome to all of you in this video lectures. Here I am going to continue the chapter set. In this video lectures I am going to discuss about the types of sets and subsets, equal sets. So students, what are the different types of sets? You can see in the screen the first type of set is empty set. So students, what is empty set? A set which does not contain any element is called empty set or null set or void set. So students, the set which is having no element, okay, but it is an defined set. For example, x such that 1 less than x less than 2. X is a natural number. So students, there is no natural number between 1 and 2. Alright, so there is no element found in this set. Okay, so this type of set is called null set or empty set. So students, the next is finite set. A set which is empty or consists of a definite or countable number of elements is called finite set. So students, finite set is those type of sets where the number of elements can be countable. Okay, we can count the numbers. Such type of sets are called finite set. For example, W be the set of days of the week. Okay, so there are 7 days, so we can easily count and write the set. So W is finite. Infinite set, a set which having uncountable number of elements. The students, you cannot count actually how many elements are there. So those type of sets are called infinite set. For example, let G be a set of points on a line. So students, on a line there are many points. So there is not possible to count such points in a straight line. So G is infinite set. Okay students. Next is, what is equal sets? When two sets are said to be equal. So two sets A and B are said to be equal if they have exactly same element and we write A equal to B. Otherwise the sets are said to be unequal and we write A not equal to B. So students, equal set basically the elements of both the set must be same. The order may not be same, but elements must be same. For example, you can see one example is given. A is a set having elements 1, 2, 3, 4 and B is element. B is a set having elements 3, 1, 4, 2. So if you compare these two sets, you can see that elements of A, all the elements of A present in elements in B. Okay, so and all the elements in B present in A. So such type of sets are equal set. So you can write A equal to B. So students, next, what do you mean by a subset? A subset of B, A is a subset of B if A is an element of A implies that A is an element of B. So students, subsets means subsets A of a set B means A is a subset of B. It possible when every element of A must present in B, then A is a subset of B. So you can see that we write A is a subset of B. If A is not a subset of B, we write A not a subset of B. So students, A is a subset of B implies A belongs to A. Small a is an element of capital A. Small a is an element of set A, and which implies that small a is an element of set B. Okay students, it is basically a set formed from some or all the elements of the set B. Here the set B is called a superset and set A is a subset of the set B. So students, there are some points to be noted. If A and B are the same set, so that A is a subset of B and B is a subset of A, then we can write A equal to B. Every set A is a subset of itself. So A is a subset of A. Since the empty set phi has no elements, so student, this is the symbol of empty set phi. Phi has no element. In empty set we know that there is no element, so we can say that phi is a subset of every set. For example, Q is a rational number of a subset of R. Q is a rational number is a subset of R of real numbers. So students, all the rational numbers are present in real numbers, right? And in real numbers, all the rational numbers and irrational numbers are present. So we can say that Q is a subset of R. Now students, what do you mean by the proper subset? Let A and B are two subsets, and if A is a subset of B and A not equal to B, okay student, then A is called a proper subset of B and B is called a superset of B. For example, B having a set 1, 2, 3, 4, and we're taking a few elements from B, 1, 2, 3, another set is formed A equal to 1, 2, 3. So you can say that A is a proper subset of B, okay, and B is the superset of A, right? So students, I hope all of you understood the concept of subset and the proper set. Next, I'll discuss about the different intervals of a subset of R. So first of all, open interval. The students, open interval is defined by this bracket, first bracket, okay. It is meaning that both end is open. Let A and B belongs to R and A less than B. Then the set of real numbers Y such that A less than Y less than B is called an open interval and is denoted by AB. So this is how we can denote AB in an open interval, where the number lies between A and B except A and B. Closed interval means including A and B. If this is the third bracket using for closed interval, the interval which contains the endpoints also is called closed interval and is denoted by AB. It means that all the elements from A up to B, okay, here with A and B, the elements lies between A and B. So it symbolically you can write X such that A less than equal to X less than equal to B. So students, what are the different intervals? Other intervals are also there, like left open, right closed. So it is an interval where A is closed and B is open. So X such that A less than equal to X less than B. Okay students, so is an open interval from A to B, including A but excluding B. Here excluding A but including B, it can be written as X such that A less than X less than equal to B is an open interval from A to B, including B but excluding A. There are some example given. You can see here the same example is given in terms of bracket. So open bracket 2, 8, it means that X lies between 2 and 8, okay, excluding 2 and 8. Here 2 is closed bracket 2 and 8. So X 2 less than equal to X less than equal to 8. Here including 2 excluding 8. So 2 less than equal to X strictly less than 8. Here excluding 2 but including 8. So students, here 2 less than X less than equal to 8. So I hope students you understood the concept of intervals. Here I'll discuss number of elements of a set. How to define the number of elements of a set. So students, number of elements of a set, suppose A is a set such that A having elements 2, 4, 6, 8, 10, 12. the number of elements of the objects in the set is defined by small n in bracket A. The meaning of this is how many elements are present in the set A we can write here. So since there are, you can see 1, 2, 3, 4, 5, 6 elements are present, 6 numbers are present. So we can write n of A equal to 6. So students, next I'll explain what is power set. So students, power set is the collection of all subsets of a set is called power set of A. And it is denoted by P of A, capital P in bracket A. So students, collection of all such subsets from a particular set is called the power set. For example, a set A here is 1, 2. So the possible subsets you can form from these subsets from this set are 1. Taking element 1, one set will be formed. Taking element 2, one set will be formed. Both are subset. 1, 2 itself is a subset of A and 5 is a subset of every element. So these 4 elements, 4 subsets together form a set. Okay students, the 4 subsets formed from the set A together form a set which is called the powered set. So powered set means the possible subsets formed from a set is called the powered set. And students, how many elements in the power set present we can find using a formula. We can see here how many elements are there. 1, 2, 3, 4 in the power set. So n p of A equal to 4 equal to 2 square. Okay students, so 2 square means, so we can derive a formula n of p A equal to 2 to the power m. What is m? M is the elements present in the set A. Okay students, so I hope you have all of you understood the concept of power set. Now I'll discuss what is an universal set. The set containing all objects or elements of which all other sets are the subsets. The universal set is usually denoted by capital U and all its subsets by the letters capital A, capital B and capital C. Actually students, universal set is the superset of all the set. Superset of all the set. Suppose the capital ABC are the set of natural numbers. Some natural numbers, suppose A is odd natural number, even B is even natural number and C is the prime numbers. In such case, the universal set will be the set of natural numbers. It is the superset of all the set ABC. That means ABC are the subset of the set U. Then U is called the universal set. So I hope students you understood the concept of superset, subset and the equal set, what we have discussed in this video lectures. Here I am going to discuss some questions. The first question is, which of the following are example of null set? So student, null set, as I have explained, null set means it is a set where there is no element. The question is set of even prime numbers. So students, is there any element even prime number? Yes, only 2 is an element which is even prime number. So it is not a null set because 2 is present. Okay students, so 2 is the only element in this set, so it is not a null set. Second one is x such that x is a natural number, x less than 5 and x greater than 7. So students, it is a null set because we cannot find a value x for which x less than 5 and x greater than 7, where both the inequality satisfied by x, so there is no such numbers, no such natural numbers, so it is a null set. Number 2, which of the following are finite and infinite set? The students, finite means countable number of elements, infinite uncountable number of elements. So in the set you can see that 1, 2, 3 dot 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 dot. So it means that there is no end, it is going on. Okay, it is a set of natural numbers going on. Last term is not present in the set, so you can say that it is an infinite set, countable, uncountable number of elements. Next one is the set of prime numbers less than 19. So obviously it is a countable number of elements present in that set, because you can collect the prime numbers less than 99, so it is a finite set. Third one, the set of numbers which are multiple of 5. It is an infinite set, because multiple of 5, there are uncountable number of multiples of 5 are present. So students, third question is, in the following set, whether A or B, A equal to B, we have to check. Okay students, in the set A, the elements present are 4, 8, 12, 16. Alright, in B, 8, 4, 16, 12, the orders are different, but elements you have to check whether all the elements are present, matching or not. 4 is there, 4, 8 is present, 12, 16. So you can see that all the 4 elements are present in B and no extra elements are present in B. So elements are same in both the sets. So you can say that A equal to B. So students, next question is, X is set given X such that X is a multiple of 10 and B is a set given in roster form. The elements are 10, 15, 20, 25, 30. So students, we have to check whether A equal to B or not. So first we have to find the set A in roster method. It is given in set builder form. So its question is, A is a multiple of 10. So multiple of 10 means 10, 20, 30, 40, dot, dot, dot. We can see that here are 15 and 25. Such elements are not present in the set A. So elements are not same actually. All the elements are not same. So the set is not equal. So A not equal to B. Alright. The third question is, A equal to 2, 3 and B equal to X such that X is a solution of this quadratic equation. So students, set A is given in roster form. There are 2 elements, 2 and 3. And set B, we have to find the solution for X, and after the middle term factorization we will get the value of X are minus 2 and minus 3. So you can see that the elements are not equal, not same. So here A not equal to B. Alright students, I hope you are understanding. The next question is, we have to check that mark correct statements by filling in the symbol subset, not a subset, in the blank space. So students, I hope all of you understood the concept of subset. Okay, the first set is a subset of second set or not, we have to check. So let us check the elements of first set present in second set or not. The elements are ABC, elements are ABC. So yes, it is a subset. This is a subset of this. So in this space, this symbol we can put subset. Next question is, X is a student of class 11 of your school, and another set is X is a student of your school. So it is a subset because second set is set of all the students in the school, and the first set is students of only class 11 of your school. So yes students, this is a subset of this set. So you can put this symbol subset. So students, next one is X such that X is a triangle in plane. X is a triangle in plane and X is a rectangle in the plane. So students, it is not a subset because this set is a set of triangle and this set is a set of rectangle. So triangle cannot be formed from a set of rectangle, right students? So this is not a subset. So another question is that it is related to subset. We have to examine whether the following statements are true or false. So AB is not a subset of BCA, but here AB is present here, so it is a subset, but since it is given not a subset, the statement is false. Second question is, AE is a subset of X is a vowel in the English alphabet. So you can see that the vowels are A, E, I, O, U, and in the first set the elements are AE. So you can see that AE is present in second set, so it is a subset, so it is true. Third question is X is an even natural number less than 6, and second set is X is a natural number which divides 36. So students, you have to write both the set in roster form. X is an even natural number less than 6. So even natural number less than 6, only two elements are there, 2 and 4. And X is a natural number which divides 36. There are many numbers which divides 36. 2, 4, 6, 12, 18, 36. So 2 and 4 are present. Here 2 and 4. So we can say that this set is a subset of this set. So already subset given. So this statement is true. So student, the next question is, let A equal to 1, 2. These are the elements present in A. 1, 2 in second bracket 3, 4. This together 3, 4 in a second bracket is an element of A. There is a pair of element in terms of set, 5. So students, we have to confirm that the elements present in the set A are 1, 2, in second bracket 3, 4. This is one element, 5. Now, which of the following statements are incorrect and why? The question one is 3, 4 is a subset of A. It's true or false? So student, it is false because 3, 4 is an element. Second bracket 3, 4 is an element. It is not a subset. Okay students, so I hope all of you understood. If you put one more bracket over here, then it forms a set. Then these statements will be correct. So now it is false because it is an element, it is not a subset. Next one is 3, 4 element belongs to A. It is right because 3, 4 is an element which belongs to the set A. It is true. So see student, this forms a set. 3, 4 is an element. When you put another second bracket, it forms a set, and this is a subset of A. True, because 3, 4 is an element, but this is a subset of A, so it is true. So I hope students you understood this question also. Next one is, write down all the subsets of the following set. So here we have to use the power set. The first question is only one element. So students, let the element is defined by capital A and capital PA, the number of subsets that can be formed from this single elements are, the elements itself is a subset of this set and phi. So this is one set and phi. So this is a power set of A. Question number 2 is 1, 2, 3. Let A equal to 1, 2, 3, and these are the 1 is a subset of this, 2 is a subset of this, second bracket 3, second bracket 1, 2, second bracket 1, 3, second bracket 2, 3, second bracket 1, 2, 3, and phi. All the elements are subset of A, and writing in another second bracket, it forms a power set of the given set. So students, next question, write the following as intervals. You have to write as an interval. So question number 1 is X such that X belongs to R, -4 less than X less than equal to 6. So students, here -4 is strictly less than, so it is excluding -4. So open bracket -4, and here X is less than or equal to 6, so including 6, so it closed bracket 6. That is the interval which can be defined this set. Second one is X such that X belongs to R, -12 strictly less than X strictly less than -10. So it's both sides is open bracket, so -12 comma -10. So students, here some more questions are there. Write the following as intervals. The question is X such that X belongs to R, -4 less than X less than equal to 6. Here -4 is open, so -4 open bracket, 6 closed. Here is -12 less than X less than -10, so -12 open bracket, -10 open bracket, write the following intervals in set builder form. Here the question is given in terms of interval and we have to form the set in terms of set builder method. Write the following intervals in set builder form. This is the interval, closed interval 6 and 12. So students, here including 6 and 12, so we have to use 6 less than equal to x less than equal to 12. Okay, here all the elements from 6 to 12. So this symbol is less than equal to, this is less than equal to. It means that the elements from 6 to 12 are present in this set. It is minus 6 to minus 1. Same, minus 6 less than equal to x less than equal to minus 1. So students, the next question is, what universal set would you propose for each of the following? The set of right triangles, the set of isosceles triangles, and a set of all types of triangles. So students, actually the two sets are given, the set of right triangles and set of isosceles triangles. So here we are talking about the different types of triangles. Okay, and our question is, what type of universal set we can propose so that these two sets are the subset of the universal set. So you can write the universal set as the set of all types of triangles. Set of all types of triangles. So students, I hope all of you understood today's video lectures. I am ending my today's video lectures. Here I have discussed about the different types of sets and the various intervals of set, equal set, and the related questions. So students, if you have any queries, any doubts, you can contact me. Thank you very much.